Okay, so hopefully you can see the problem of the day here. Let me know if you can't. But it says a thoroughbred racehorse accelerates uniformly at 7.5 meters per second squared, reaching its final speed after running 19 meters. If the horse starts at rest, what's its final speed? So, givens, right? What do we know the problem here?
It accelerates from uniformly 7.5 meters per second squared.
Yeah, so which quantity is that then? The 7.5? Is that...
Acceleration.
Yeah, that's acceleration, right? I think you said that, sorry. Yeah, acceleration is 7.5 meters per second squared. Good. Other givens?
The final speed?
Yeah, the final speed, right? What's the final speed?
19 meters.
Wait a minute.
I
19 meters.
I mean, sorry.
That's delta x, right? 19 meters is delta x. That's the displacement. Good. So do we have the final speed?
That's the unknown.
That's the unknown, right, Jose? It's asked us, right? If the horse starts at rest, what is its final speed? So it says it reaches its final speed after going 19 meters, but it doesn't tell us what it is. If that's actually what they're asking for. And one more thing we can is a given that we can assume.
The initial, which would be 0.
Right, exactly. Our initial speed is 0, right? The horse starts at rest. Good. So we've got acceleration, final velocity, displacement, and initial velocity as our symbols. So which of the big 4 equations are we going to need to use here?
The last one.
Yeah, the last one, right? The one that's VXF squared is VXI squared plus 2AX times delta X, right? That's the only one that has those 4 symbols. So we'll copy that down over here. And I don't really need to rearrange anything, right? I'm looking for my final velocity, and that's all by itself on one side. I just need to remember I'm going to get the final velocity squared, so I'll have to take the square root at the end to get the velocity. So I can plug in my numbers, right? VXI is just 0, and so VXI squared is still 0. So plus 2 times 7.5 meters per second squared times 19 meters. That's going to give us 2 times 7.5 times 19. That's 285. And if I look at my units over here, I've got meters per second squared times meters. That really gives me meters squared over seconds squared, which is a weird unit until we remember we have to take the square root, right, to get our VXF. So when I take the square root of my last answer, it's 16.88. So what I get is VX final equals 16 I'll round that up to 16.9. And then it's going to be meters per second, right? Because if I take the square root of meters squared, that's meters. And if I take the square root of seconds squared, that's just seconds. So 16.9 meters per second would be our final velocity. And I know a lot of people that submitted the problem of the day answer yesterday got that. So that's a good sign. I know Jose got it.